In this video, we are going to do two questions. One that's based on tangent from same exterior point and other properties of circle. And the second question is an MCQ, which is also based on tangent from same exterior point. So let's begin with the first one. In this question from the chapter circle, it says in the below figure, two circles are given. Yes, we are seeing two circles here with centers as O and O dash be their centers. And they touch each other at point X. So I can see that these two circles touch each other externally at point X here. Further, it says that O dash, O is the centers. O and O dash both are centers. They are joined and it is produced to point A. All right. Now we are given AC is a tangent to the circle. That's AC being the tangent to the circle. This is a tangent to the circle with center O, right? That means the other circle with center O, where the C is the point of contact. Further, it says that this is given as 90 degree. That means we are given this that is O dash C. You can see O dash C is perpendicular to AC. So this angle is 90 degree. What else we have to prove here is the ratio, not prove. We have to find the ratio of OD dash to the ratio of this. These are the two lines whose ratio we have to obtain. Now, the two property which we are going to use in finding the ratio, one is the radius is perpendicular to the tangent at the point of contact. This is the radius and this is the tangent. So radius is perpendicular to the tangent at the point of contact. So let's write it down. What I'm going to write is angle. We have angle ACO is equal to 90 degree. And you may write down the reason that radius is perpendicular to the tangent at the point of contact. The other property which we are going to use is the property of similarity. That is, when two angles of a triangle are equal, they are similar. So by that, I mean to say that we are going to prove triangle this, that is one that is shaded yellow here. And the other triangle, let me, if I shed it with blue, right? I'm going to prove these two triangles as similar. And for proving these two triangles similar, I'm going to use that angle similarity. As you can see, these two angles are 90 and we have one angle this has common. So I can write the triangles as similar. So we need to prove here in the exam. So I'm proving it as you should do in the exam. So I'll take the triangle ADO dash and the other triangle it is ACO. Here I can see angle A is equal to angle A and that is the common angle. And further we have this angle ADO is equal to angle ADO dash is equal to angle ACO. And these two angles are equal because each is 90 degree. Now, once you have proved two angles equal, I can say that triangles will be similar. So I'll write that triangle that is A. This is DO dash is similar to triangle ACO. And the condition is A similarity. As you know that when two triangles are similar, their sides are proportional. So I'll be writing their sides, say AD. We don't need AD, so let's ignore AD. I can say that AO dash, their corresponding side, and AO should be equal to DO dash over CO. Now, what you have to observe that these two circles are equal. So their radius must be equal. So this is R here. So this is also R. And this would also be R. Now, what you can see that AO dash, right, from here, AO dash will be equal to R. So I can replace AO dash with R. Now check for the other one. They're also asking about this one, right? Can you see this? This is actually R plus R plus R. AO is r plus r plus r, that is 3 times r. So I can replace AO with 3r, 3r, and that should be equal to what? DO over DO dash. This is DO dash, DO dash over CO. Now, if I cancel these, I'll get what? 1 over 3. So the required ratio is what? 1 over 3. As you can see, this is what they asked for, DO dash over CO, and we got this. You may write this as 1:3. So this is how we can do this question. In the next question, it says two circles touch each other externally at point C. So let's first draw till here, then we'll be able to understand it better. I've drawn two circles. Let's say these are the two circles, and I took the point, external point, as C here. Now further it says that AB is a tangent. Well, is a tangent can be drawn like this also, which is a common tangent, right? AB is a common tangent. But when you see the question, it's not saying that it is passing through C. So I can draw another tangent. Let's say I've drawn these a tangent and I name it as AB. Well, AB the contact of this circle and B is the point of contact for this other circle. What we have to determine is angle ACB. That means joining A with C and also with B. We have to determine the value of this angle, and I can show you the triangle angle, this one. This is what we have to get. Well, to do so, what I'm going to do is to draw another tangent, right? And that should pass through that tangent should pass through O. So this is a tangent, which is a line and not a line segment, right? And I took this point, I can name it as M. This is should be uppercase of M. Now we are going to use the property of tangent from same exterior point. From tangents from same exterior point, what I can say that this line AM should be equal to CM. That's from tangent from same exterior point. And if these two sides are equal, consider this triangle. The triangle here is, well, this one, coloring it with, shading with yellow. Sorry, green. All right. So now let's take the triangle first. The triangle here, I should also write down as you should write in the exam. That is triangle AMC. Well, this is an MCQ, so you may skip the steps. But when it comes in the exam, without an MCQ, you have to do it. So in this triangle, I can see that AM is equal to CM, and the reason is tangent from same exterior point. So, and on the other triangle, but let's first deal with this part. Can I say that therefore these two angles will be equal? That is angle MAC should be equal to angle MCA, right? And that is from isosceles triangle property, or you may write angles opposite to equal side. So these two angles are equal, and then mark these two angles as X. So I marked it as X. So this is X over here, this is X over here. Similarly, we can also figure out on the other triangle, let's say this one. Here too, you can observe that from tangent from same exterior point, I can write these two sides as equal. Say these are the two. So from tangent from same exterior point, here to these two sides will be equal. And that's how we can say that this angle should be equal to this angle. I took it as Y. So like the previous case, here also we have to write down, that is in triangle, this is BMC, we have BM is equal to CM, and this reason is tangent from same exterior point. Now, same way I can write using this same property, I can say that angles opposite to equal sides are equal. That is angle MBC should be equal to angle MCB, and I took this angle as Y. Now check here, we have to find what? Angle ACB. Well, when you see the figure ACB now, it is X plus Y, am I right? X plus Y. Now, Finally, we are going to use angle sum property. And in this triangle, that is the triangle ABC, what I can see, there are three angles. One is angle A, other is angle B, and the third is angle ACB, and which is equal to 180 degree, that is by angle sum property. Replacing A with X as for the figure, replacing B with Y, and this is ACB, which is X plus Y, is equal to 180 degree. Now check, let's club these together. Can I say this is 2 times X plus Y is equal to 180 degree? That implies X plus Y will be what? On transposing 2 to the other side, it should be 90. Well, this is angle X plus Y. Well, X plus is Y is what? Angle ACB. That is what we are looking for. So that comes out to be 90. Repeating, this is angle ACB. That is X plus Y. X plus Y is ACB. That's how we say that ACB is how much? 90 degree.